You ready? Class. Okay. Thank you. You didn't even say yes. That's messed up. What you guys thought? You forgot what to say? It's been that long? Oh my goodness. After all these years.
These years?
All these years.
Isn't it just 2 years?
This is year number 3.
Oh, yeah.
Yes. So, anyway, all right. So, rates of change and the derivative. So, again, these are using the old textbook. These are not using the new textbook. The new textbook is grossly inadequate for this topic. So, I'm just going ahead and use these ones because these ones actually go into detail, and I'm hoping that's going to be helpful. Now, rates of change and the derivative. So, now, definition of a tangent line. Now, first, tangent means it is touching at a single point. Tangent line to the graph at a point P is containing the point having the slope, okay, exists, okay. So, all these things, we're finding the limit as it approaches that number for the tangent, where M is going to be the slope of the tangent at that point. So if we talk about, like, if it's a sine wave, something like this. This looks more like a cosine, but anyway. All right, so right here, this line would be a tangent to this, touching it at a single point. So that's the tangent line. And that's what we're going to be finding. Find the equation for tangent line and the normal line to the graph of a function. Now, if the slope of the tangent exists, then the equation of the tangent line to the graph of the function at the point, okay, whatever C and C of f is, okay, where f prime, which is this, f prime of C is the slope. F prime of C is slope. Like I said, these notes are kind of backwards, kind of messed up, but still, go with it. All right, so that right there, this is f prime, which that is my slope. The line perpendicular to the tangent line at point P on the graph of a function is called the normal line. So if it's perpendicular to the tangent, let me go back to my little diagram right here. So I have a tangent line here. The perpendicular would be going here. So it is creating a 90-degree angle with the tangent. Yes? Yeah, meow? Okay? Okay, good. So tangent touches it there. Normal is perpendicular to the tangent. So you guys remember that little box that you put in there? Perpendicular means creating a right angle?
Yeah.
Okay, good. Just making sure. All right, so the equation of a normal line to the graph of the function right here is this, but you know what? That's a hot mess. Don't worry about all that. Because if my slope of my tangent is 2 over 3, what would be perpendicular to 2 over 3?
Negative 3 over 2.
Negative 3 over 2, very good. So negative 3 over 2, so you opposite reciprocal. So opposite reciprocal. This is a complicated way of saying do the opposite reciprocal for the slope. That's all it is. So provided f prime of C exists and is not equal to 0, then f prime of C is equal to 0. The tangent line is horizontal. The normal line is vertical. Right here. So my red line is a horizontal line. The slope there is 0. The blue line is perpendicular to that. So my blue line has a slope of undefined. Does that make sense? So if my slope here is 0, perpendicular would be undefined. So if you think about it, so rise over run, so if it was in between these 2 points, rise would be it goes up 0, but it goes over 3. So that gives me 0. But if I do the opposite reciprocal, so that would give me 3 over 0, which is
Undefined.
undefined. That makes sense? So it went up 0, but went over 3. Then opposite reciprocal of that. Okay, investigating an infinite limit. Find the slope of a tangent line to the graph here at c equals -2. Insert page blank after current. So it was f of x equals, was it x squared? Yeah, x squared, and c is -2. Find the slope. So we're going to use the limit process to find this right here. So using the limit process, I'm going to find that out. So I'm going to go through and I'm going to do, remember it was f of x plus h minus f of x over h. You guys remember that?
Yeah.
And that's the limit as h approaches 0. Yes, no, maybe? Kinda? Yeah. Yeah. And so if my function is x squared, my function is x squared, so let's go ahead and plug that in. So it's going to be x plus h closed squared minus x squared over h. So we're doing the full limit process here. Then I expand it. This is going to turn into x squared plus 2xh plus h squared minus x squared all over h. Agree, disagree, maybe, possibly. You guys remember expanding it?
Yeah.
Yeah, hopefully.
Can it be?
Okay, so x squared and the minus x squared is going to clean up. So I'm going to be left with, let's see, h squared plus 2xh over h. I can factor an h out of the top. I'm left with h plus 2x over h. What's going to happen to those h's?
They cancel.
Those are going to cancel right there. And then now can I do the limit as h approaches 0?
Yeah.
So now I can plug in 0. So I'm going to get that it's going to be f prime of x. So this is another way of actually saying it. It's f prime of x. So if this is the function, f prime is going to be the equation of the slope of f prime. That's what that means. So f prime, so as I plug in 0 there, I'm going to get 0 plus 2x is just going to give me 2x. Am I making sense, or is this too early on after a week of break? Denny, are you tracking? You good? Yeah. If I'm saying something crazy, please speak up. You don't like it? A lot of work?
It's a lot of work.
A lot of words. Words are a bad thing, especially in math. Hate all word problems. But being dyslexic, it actually makes it even worse. Because word part of your brain is not the same as your analytical part of the brain.
Okay, and the pre-calc way and the calculus test is fair on this.
Yeah, it's all applied math. So, I know. All right. Anyway, are you okay with this right here? Are you guys okay with that?
Define the F prime.
F prime. Right here, it's going to be, see this right here? The slope of the tangent, right?
Slope of the tangent.
M tan, that's the slope of the tangent, is the limit function here, right? Where I rewrite this as f prime of c is the limit function.
So that's rewritten version.
Yes, it's rewritten. So if the limit exists, f prime is going to be the equation of the tangent. There's another way of actually, if this exists. Yeah. So it is the equation of the tangent. So now, given this information here, I could find the tangent or the slope of the tangent at any single point. The point that I'm looking for now is where? I'm looking for it at -2, right? So now I'd plug it back in. So f prime of -2 is going to be 2 times -2, -4. So the slope of the tangent line when x equals -2 is going to be -4. You'll see. Insert page. Let's go ahead and graph this. So my function is there, right?
Yeah.
So it's a parabola, isn't it?
Yeah.
Yes. So I'm going back to what I said. I said that f prime of -2 is -4. So when x is -2, which is right here, at this point right here, the slope of the tangent line is going to be -4. So the tangent line touches it at a single point right there. So the slope of that is going to be -4 now. That's what we went and found. Does that make sense now, or is that nonsense still? Okay? So given this information, the f prime information, that we had f prime of x is to x, I could find the slope at any point of the tangent, right? So if I do +1, just looking at the graph, if I were to draw a tangent that touches it at one point right here, right there, at +1, I know that my slope has to be positive, doesn't it? Looking at it, reading from left to right, my slope is going up. So I can go f prime of 1 would give me 2. So the slope of the tangent line touching it at the point 1 right here is going to be 2. Does that make better sense, or is that nonsense? Hopefully a little bit better. Meow meow. Okay, are we okay? Yes.
Yeah, I
changed my water bottle. I took Casey this morning. And I'm like,
Okay. Okay. You should buy some from your teacher because I think he sells good bottled water. I think. I don't know. He's kind of a jerk though. All right. So use the results from A to find the equation of the tangent line when C is -2. Okay. So let's go on back again. So now we have the equation. So that means that the x value. I'm going to change up colors. So my x value, x equals -2. My m value was -4. And what is the last thing I need to find an equation of a line?
the y-intercept.
The y, not y-intercept, just the y value. Just the y value, that's all I need. So, I know what the x value is. Could I plug in the x?
Yeah.
We could plug in the x right there too to figure out where it touches. So let's plug in the x. So that's going to be, so f of -2 is going to be +4. That means my y value, +4. Now let's see what that all means together. So it's y minus 4 equals -4 quantity x plus 2, or x minus -2. Yep, this is point slope. And I'm going to go back to my graph so we can see why and where. This location right here is 2, 4, right? Yes?
Yeah.
And so that 2, 4 is touching my tangent line. So it's for my tangent line, and it's also touching my function line, the one in red. So it's doing both. So that point right there is in both equations. So that's why I plugged in my 2, or I'm sorry, my -2. That's -2 there. I plugged in my -2, and I got my +4. Does that make sense, or is that nonsense? I know these are a lot of things, so I need you guys actually, at least communicating with me. Tell me I'm crazy. Go ahead. Yes.
So is that, so we're going to do that.
Eventually, but not really so much circles. We're going to be do arcs, but not. Can't do the whole circle because those are undefined. Because you're going to have the top and bottom. You can do at different times, though. All right, so that was B. So now find the equation of the normal line to the graph of the function at point 2, -2, 4. So if my f of x squared, and f prime of x equals 2x, and so now we're trying to find the normal. The normal. So if f prime of -2 is -4, remember, this is the tangent. And I said that the normal has to be what to that? It's perpendicular, right? So if I know the normal slope, what would be the perpendicular slope? What's perpendicular to -4?
1 over.
+1/4, right? It's opposite and reciprocal. 1/4. Is that crazy? No? There's a lot of crazy stuff going on there. So now I have the perpendicular. So let's go to my graph. So now instead of going this way, it's now going to go this way, creating a 90-degree angle to the tangent. Right?
You don't microwave by chance, do you?
I kind of do. Why?
Oh. Maybe for lunch.
No! Now! All right, so do we have the points? Yes, we do. We have the points, right? This point right here, it's in my function, so it's touching my function, it's touching my tangent, and it's also touching my normal. So I'm going to use the normal, my slope, positive 1 over 4, and let's find the normal line. So normal line would be y minus 4 equals 1 over 4 x plus 2. I just plugged in my x and y, and I just plugged in my normal slope. Yes, no, maybe? Again, this is a lot of information for each one of these. But I want to try and go in detail as much as I can. So graph the function. Oh, hey, look. We already did that earlier. So you graph the function, the tangent line there, and the normal line there, on the same set of axes. So the black one here is my normal. The blue one is my tangent. And the red one is my function. Is my function. You guys need some more paper for the drawing and the stuff. I do have more scratch paper. I want to add stuff to your notes. Yes? All right, so we have everything there. Now, before I actually do the average rate of change, I'm going to leave off here. I want you trying to sample some of these problems. Go through. We did the limit process to find the slope. Limit process, take h approaches 0. And then from there, okay, we had the equation of the f prime. That's the equation of my slope at any given point. And then we just solve through the rest of those. So make sure you all like, share, subscribe, hit that notification button, support my channel. You're not supporting my channel, you guys.